This is section 5.1. We are solving inequalities. And today we're using addition and subtraction to solve our inequalities. So, can you guys solve an equation? And you can totally handle inequalities. Okay? Solving an inequality is very similar to solving an equation. We're going to add and subtract today to solve to get the variable by itself. To start off, let's look at some verbal sentences. So if I said the difference of a number and 12 is no less than 15. So I want to change these words into algebra. When it says the difference of a number and 12, what operation does that make you think? Subtraction. What two things are we subtracting? A number and 12. So let's write n minus 12. You can use whatever variable you want. Now this is new. It says is no less than 15. Okay? No less than is a new phrase. If we said less than, we would know that that's that symbol right there, wouldn't we? Okay, if it says no less than, think of it as not less than. It's not less than. What is it? Greater than or equal to. It's not less than. The opposite of that would be greater than or equal to. Not less than what? 15. So on your notes page, I want to make sure that you make a note of this. If it says no less than, we're thinking greater than or equal to. Make sure you've got that written down for this example. And that, for now, that's all we're going to do. We're just going to write the inequality. Eventually, we'll solve it. Number 2 says 3 times a number is at most 12. Let's just break this apart. What does 3 times a number look like? 3n or 3x, whatever variable you want to use, is at most 12. Does anybody know what at most means? That's correct. Very good. At most is less than or equal to. Less than or equal to. At most 12. So no less than is greater than or equal to. At most is less than or equal to. Okay. They're saying at the very most, the highest it could be is 12. So that would mean this is smaller, isn't it? Okay, so inequality is eating that bigger number. Number 3, 8 plus 4 times a number is greater than 5 times the number. So let's break this apart. 8 plus 4 times a number. What would that look like? 8 plus 4 times a number. There we go. 8 plus 4 times n. Is greater than 5 times the number. What symbol would greater than be? Greater than or greater than? First one? Second one? First one. That's the greater than symbol. Greater than. Does it say greater than or equal to? No, just greater than. So we just want the greater than symbol. Greater than 5 times the number. Well, what would 5 times the number look like? 5. Okay, for right now, I'm not worried about solving. I just want to practice writing the inequality. So there's going to be some phrases that mean less than, greater than, less than or equal to, greater than or equal to, that we need to be familiar with. Another one that's not on here, but I want you to be familiar with, is at least. Can you write at least down on your notes? Just somewhere on the paper. At least is greater than or equal to. Questions so far? Let's work on graphing next. It says to graph the following. I want to graph on a number line all the real numbers that are less than 2. all the real numbers that are less than 2. Write that down. I'm using x for all the numbers that are less than 2. Now we talked about open and closed circles when we did the piecewise functions, didn't we? What did we learn we should use, an open or closed circle, if it's just less than? An open. So I want you to draw a circle, an open circle at 2. And I'm going to put it just a little bit above my number line, not on the number line, but just a little bit above. Open circle at 2. Now what are the numbers that are less than 2? 1, 0, -1, -2. We found those numbers that were less than 2 when we did our t-charts, didn't we? We're going to draw an arrow going this direction because those are all the numbers that are less than 2. Today when we solve inequalities, we're going to graph our answer on a number line. We're going to represent all of the possible solutions on a number line. Now, a little trick I want you to look at for me. If you look up here at this inequality symbol, if I make that into an arrow, what direction is that arrow pointing? What direction did my graph go? Same direction. Look at number 2. I want to graph all real numbers that are greater than -2. Let's write what that's going to be. All the real numbers greater than -2. So on this graph, would you use an open or a closed circle? An open circle. So at -2, please put an open circle. Now what numbers are greater than -2? -1, 0, 1, 2, 3. The numbers that are going to the right. So I want you to draw in an arrow going to the right on that graph. Like in the last example, if I had looked at this inequality symbol and I made it into an arrow, that inequality is pointing to the right, just like my graph is pointing to the right. Number 3 says all real numbers less than or equal to 1. All real numbers that are less than or equal to 1. X is less than or equal to 1. With that symbol less than or equal to, would we use an open or a closed circle? A closed circle. So at 1, please put a closed circle. What direction am I going to draw my graph to show all the numbers that are less than or equal to 1? The left is correct. And again, I can make an arrow out of that inequality symbol. Number 4 says all real numbers greater than or equal to 0. Greater than or equal to 0. So x is greater than or equal to 0. So at 0, would you use an open or a closed circle? A closed circle. How do we know it's closed? It's equal to, just like we did on our piecewise functions. Equal to. Now what direction are we going to graph this to show all the numbers that are greater than or equal to 0? To the right. And that's pointing to the right, so that's the direction my graph is going to go. Alright, do you think you guys could graph on a number line if I asked you to? Look at this next one. It says Matt was sure he didn't score less than 73 on his algebra test. Write an inequality to describe Matt's possible score and then graph the inequality. Alright, so Matt took in a math test, an algebra test, and he's positive he did not score less than 73. So what is not less than 73 look like? Not less than 73. Somebody may have said it. It's not less than, what is it? Greater than, could it be equal to? It just says not less than. Greater than or equal to 73. It's not less than. That represents greater than or equal to. So I want to practice graphing this on my number line. Sometimes they're going to give you an empty number line and you're going to have to put in the numbers. So I'm going to do 73, 74, 75, put 72, 71. I want you to put a few numbers on each side of 73. I've got 5 numbers on my number line. I think that's plenty. Now when I graph it, would I use an open or a closed circle at 73? A closed. And how do we know it's closed? Correct. It is equal to. Now, what direction am I going to graph this to show all the possible scores that Matt could have had? To the right. We want to the right. We want bigger score, something greater than or equal to 73. How about this one? Sue ran a 2-kilometer race in 8 minutes. Write an inequality to describe the average speeds of runners who were faster than Sue. Alright, so Sue ran it in 8 minutes. Everybody else that ran it faster than her, is their time less than 8 or is it greater than 8? Less than 8. It's kind of tricky, isn't it? Less than 2, they ran it faster. So their scores, their times are less than 8. Could it be less than or equal to? Think about it. If somebody is faster than Sue, can they run an 8-minute 2K? No, if they ran 8 minutes, would they be exactly as fast as Sue? Okay. To be faster, they have to run slower, or excuse me, they have to run faster, lesser number. So X is less than 8 represents all the people that are faster than Sue. So let's graph this on our number line. Once again, I put 5 numbers in my number line, a couple numbers above and a couple numbers below 8. As we graph it, will we use an open or a closed circle? Open. And what direction can I draw this arrow to show all the times that are faster than Sue's? Less than, to the left. Alright, so I believe the next thing we're going to do is talk about some solving. If you don't have a calculator, you might want to grab one because there are a couple of fractions on here. Decimals. As opposed to an equal sign. The only thing that's different. So if I want to get x by itself, what would I do to move the 5 to the other side of the inequality symbol? Subtract it. Let's do that. Minus 5, minus 5. Alright, so I subtracted 5. What do I have left? Well, I have x. I have greater than or equal to. 3 minus 5 is negative 2. Inequality symbol doesn't change at this point. We haven't done anything to affect it. Now, I do want you to get in the habit of graphing your solutions. Every time we're going to put them on a number line to show all of the solutions. So on your number line, let's go ahead and put a few numbers bigger and a few numbers smaller. Sometimes students get their negatives backwards on their number line. So check your number line once you've got it. Does it look similar to mine? It doesn't have to have the exact same numbers. But what I want to say is the bigger numbers are always on the right, the smaller numbers are always on the left. Sometimes students will do this, -2, -3, -4. See what I mean? As far as backwards, this won't work. Okay? This one's wrong. You don't want to do that. Alright, so when we graph this, are we going to use an open or a closed circle? A closed circle at -2. And once again, when I graph, I always put it just above the number line because it's really hard to see if our pencil gets right on that number line. So just put it above and make things a lot easier for me. What direction is our graph going to go to represent all the numbers that are greater than or equal to -2? To the right or the left? To the right. Greater than. Those are bigger. Those are to the right. the back side, please. Here we have x plus 8 is greater than or equal to 1/5. Alright, if I want to get x by itself, what am I going to do to the 8? Subtract it. So I have x is greater than or equal to, so I'm going to do parentheses 1 divided by 5 minus 8. Now we have a decimal, and I would be okay with this decimal because it's terminating. I could also go to math and fraction. You get back to a fraction, it doesn't matter. I'm going to leave it as negative 7.8 for now. Now there's several different ways that I could graph a decimal on my number line. I'm going to show you a few options. One way is I can simply do negative 7.8, negative 7.7, negative 7.6, negative 7.9, negative 8. Of course, that graph is going to the right. Let me show you another option that we could do here. I could just use my integers on my number line. Where does negative 7.8 fall? Well, between negative 7 and negative 8, right? So a little bit closer to negative 8. So I can put it about right there. And draw my arrow going to the right. There's one other option we could have. What if we had chosen to use the fraction? It was negative 39/5. That would be negative 38/5. Negative 40/5, wouldn't that be negative 8? Negative 40/5 on this side. We do negative 37/5. Negative 41/5. Of course, you use a closed circle at negative 39/5. And have to be going to the right. All of these are representing the same thing. I'm not going to tell you you've got to do it one way because there's lots of options. Okay. Make sure you keep. Let's try this next one. Solve this. What are we going to do to get m by itself? Add 5.2. Go ahead and add 5.2 to both sides. Now don't go flipping sides or anything. Don't move m to the left. Leave m on the right. So 3.1 plus 5.2 is 8.3. Everybody have this written down as I have it written down? Write it on your notes, please. Because we're going to make a switch. When I solve an inequality, I want that variable to go on the left side. Just like when we solve an equation, don't we want it to be like x equals something? I want that variable on the left. I'm going to use, we call it the symmetric property. And I'm going to flip-flop sides of the equal sign. So I want to move m over, and I want to move 8.3 over here. Now, in an inequality, if I flip sides like that, what else do you think we need to switch? This symbol. That's correct. So it's really m is greater than or equal to 8.3. Please write all of those steps on your notes page so you've got a good example. If our variable ends on the right side, we do want to go ahead and flip-flop and move it to the left side. Now let's graph it. I don't care how you set up your number line. I'm going to use decimals. Am I going to use an open or a closed circle at 8.3? It's a closed circle. In what direction will my graph go to represent all the numbers greater than or equal to 8.3? To the right. Again, I can make an arrow out of that inequality symbol. It's pointing to the right, so that's the direction my graph is going to go. I've got a couple more here. Oh, this one. -2 is greater than n minus a -4. When you see a minus and negative, what have we learned that we should do with those two signs? Change, or add the opposite. I want you to do that right now. Change. So you can think of this problem as -2 is greater than n plus 4. Now what can we do to solve this inequality to get n by itself? Subtract 4. -2 minus 4 is -6 is greater than n. I haven't flipped anything. I went ahead and brought all of my problem down. In the very next step, I'm going to switch sides. I want to use that symmetric property. So I'm moving n to the left and -6 to the right. When I do that, what else has to change? The inequality symbol also needs to flip. So we're going to graph n is less than -6. Would we use an open or closed circle at -6? Open. And the graph is going which direction? Going to the left. I'm going to skip that next word problem and we're going to jump right to the next problem to solve. I want to look at these last two examples there on the bottom of the page with you. Now, do you notice in this problem I have x's on both sides of the inequality? We have to be able to keep that x a positive number. What could I do to move this x over here with this 5x? Subtract it. If I want to move a term from one side to the other, I would subtract it. So breaking everything else down, I have 5 plus x is less than or equal to 3. I've got those x's together. I need to keep that x a positive term. Now what can I do to get x alone? Subtract 5. So x is less than or equal to -2. Now I'm going to graph it. Open or close circle at -2. Close circle. What direction is that graph going? It's going to the left. All the numbers that are less than or equal to -2. One more. Look at the last example. This one has fractions, but that's no big deal. We can do this on our calculator if we need help with it. What can I do to get m alone? Add 2 fifths. Okay. So let's add 2 fifths to both sides. All right, so on our calculator, let's take 3/10 plus 2 fifths. Parentheses 3/10 plus parentheses 2 fifths. I'm going to go to math and fraction. I'm leaving this as a fraction this time. 7/10. Did you get 7/10 also? So I'm writing it down as 7/10 is greater than m. Now in the very next step, let's flip sides. Let's say m is less than 7/10. 7/10, I have 8/10, 9/10, 6/10, 5/10. Open circle at 7/10, and that graph is going to the left. That concludes our notes for today. We are solving inequalities. When we solve an inequality, where do we want the variable to end up eventually? On the left side. If it doesn't end on the left, we'll simply use the symmetric property and flip it over to the left. In doing that, our symbol also switches. What does at least mean? When you see the phrase at least, than or equal to. What does at most mean? Less than or equal to. What if I said no, not less than? Greater than or equal to. Show me with your hands, like do this or this. What does less than look like? This way, right? Looks like an L. Show me with your hands what greater than looks like. This way. Good job. All right. Today's homework is on a handout. We are doing numbers 1 through 14 only.